Okay, so what we are going to do today is we're going to pick any region, and within that, we are going to create a custom VPC, and then we are going to create a custom subnet. Then we're going to launch an instance, and then we're going to try and connect from my desktop to this instance to see what it needs to be configured across different things to be able to do that. Yeah. So the region we're going to pick is Oregon, VPC. So we have a default VPC, subnets, route tables, and everything. So we're not going to touch that. We're going to create our own VPC. So create VPC, we can give any name we want. Let's say Open Consulting. Consulting VPC. So the CIDR block I'm going to use is 10.0.0.0.0/16. So if you recall this, which would give us the maximum address range. So that's 65.536. If you minus 5, that's 531. We're not going to need all of this, but I'm just creating it. Then the next ones, we're not going to use the IPv6. I got too many zeros. Tenancy, I think we mentioned before. So the default is the shared infrastructure. If you want, there is a compliance reason, we can go for dedicated. Or if you have a fat wallet, you can try that. But we're going to stick with the default one. Okay, so now we have two VPCs here. So one is the default one. So if you look at here, default VPC. So that's the one that was created when I created the account in this region. The other one is not a default VPC. So the custom one that we have created. So what we have done now is created this layer here with this IP range, CIDR range. Okay. Okay, let's look at some of the properties we have in here. So first is the VPC ID. So this is created by AWS. Status is available. IPv4 CIDR range that we defined. We did not use v6. So DNS host names, we didn't mention any of this. The tenancy default, which is a shared. Is this a default VPC? No. Classic link? Nope. Network ACL. So these are some of the ones that we're going to touch. So it has a linkage to an NACL, DHCP options, and route tables again. So they all picked up the default ones. So these are gets created as you create the VPC. Then if you look at the subnets, so you still have those 4 subnets, which are the default subnets that we had. Had we look at everything on the VPC? Is there anything else left? Okay, so that's that. CIDR blocks, again, thing if you remember this thing, you're only allowed to have 5 CIDR blocks per VPC. So which means you can add another 4 here, but not more than that. Then you have to create your own another VPC if you want to add more CIDR blocks. We are not using IPv6. Flow logs, I think we already briefly touched it. So this is mainly to capture IP traffic flow information between the network information and resources. Tags, as Kaushal mentioned, a good naming convention. So you need to have a very clearly defined tags and everything. So that becomes quite easily manageable and structured. We are not doing it here. So that's VPC in general. So let's see what are the things you can do with the VPC. So you can delete the VPC. You can edit the CIDR range. You can create a flow log. And you can configure the DHCP and DNS. So these are the default ones and tags. So these are the actions that you can perform. So we have completed the first part, which is creating the VPC. So let's create a custom subnet. So subnet, OC subnet. So here we have to specifically point to which VPC this subnet belongs to. So in our case, we have created the default. So the default one is here. So we created a custom one here. So we're going to choose that. Availability zone. Again, I think it was asked before. The good practice is to have multiple subnets across multiple availability zones. So here we're just doing a demo. So we just choose either one or no preference at all. So this is the CIDR range for the overall VPC. So that is for this, we have a CIDR range of 10.0.0.16. For the subnet, we have to define a CIDR range. So which means, depending upon the range that you're going to define, that many number of IP address will be allocated to within the subnet. So let's double check again here. Okay, so we could have 256 IP address, so which means 251 IP address that can be allocated within that subnet. So we can have 251 IP addresses available for our custom subnet. So we have that here. Let's look at some of the properties. So subnet ID, randomly created. It associated with the custom VPC we created. So as we discussed before, the available IP addresses here, 251. We do not give any preference, so it automatically allocated that to it. It got association with the route table, which we'll look at in a minute. And the rest of the things, the owner is the account ID. I shouldn't be showing this, but anyways. IPv4 CIDR range for this, which we defined, so which means this many IPs available. Okay, and these are more at network level. We don't have control, get associated. NACL, again, it gets assigned to an NACL, which we'll look at in a minute. Auto assign public IPv4. So this is an important thing to look at. So what this means is, I think we looked at before, where if we are talking about a default VPC and default subnets, and when you launch instances within those subnets, they automatically gets a public IP. So that's by design, right? But when you create a custom VPC and you create a custom subnet and you launch an instance within it, you will not get a public IP by default unless you define that over here. So actions, modify auto IP assign, enable auto assign. So going forward, what will happen is any instances that are launched within this private subnet will have both public IP and private IP assigned to them. So that's that. Flow logs, again, you can enable here. Same thing. Route tables. So what are the route tables that are associated with this subnet? So this what trouble is associated with this, what NACL is associated with the subnet. Again, we'll look them these in detail, okay? Also, NACL, very similar. What is assigned to them? Tags, we can add tags. If you want to have a sharing with another AWS account, you could use it here. So this is slightly more advanced, but cross account access is something that can be done. The last bit to look at is what are the things that you can do. So you can delete the subnet, you can create a flow log, modify the IP address settings. You can edit the NACL association. So by default, it gets associated to an NACL and route table. You can change that here. Share subnet, visa, cross account access, tags editing. So these are basic things about subnet. So if we go back to the diagram, so we have this custom VPC created, and we've got the security group created. So let's look at the NACL route tables. Okay. So if you look at route tables, we have two route tables now here. So if you look at here, so this is our main route table. So this is associated with our default VPC. So if you look here, any traffic related to the IP CIDR range, then it knows it's a local one. Forward the traffic to the local network. If it is not related to the local range or the CIDR range defined within our network, then forward that to internet gateway. So here, if a traffic comes in and if the IP address defined in there is within the range defined here, then route the traffic here. Say, for example, a traffic is originating from here, EC2 instance, it going all the way up to the route table, and the router looks at the source and destination and says, okay, so it's related to a local network, then it passes the route back to the network, maybe another subnet. But if it is not to do with anything related to the local network, then it gets forwarded to internet gateway. So this is basically the internet gateway. So that's what the routes is. So the route table is pretty simple. So it just allows you to define, routes of, what's your destination and what's the mean and how to connect to that. So subnet association. So this is something to look into. So by default, a route is automatically allocated to all subnets. So as we mentioned before, the route tables need to be allocated to a subnet explicitly, right? But if we haven't done that, by default, the default route table will be allocated to the available subnets for which there is no route table explicitly allocated. So that's a standard allocation. So let's go back to the private VPC we have. So this is the VPC we created, and this is the route table that was created automatically when we created this private VPC, so the custom VPC. So this is the name of the route table. It is not explicitly associated with any subnet, even though it was created when it was created as a VPC. Because when we created VPC, the subnet was not automatically created, right? So we manually created the subnet. Likewise, we need to manually associate the subnet to the router. Routes. So we have the routes here, and we have subnet associations. So as we saw here, we did not explicitly allocate. So even though we did not allocate, still the route will automatically apply to the subnet. I guess in our case, the good practice is to specifically assign to the network. So here we have associated our private subnet to the route. So we have got the VPC created, we got the subnet created. We have looked at the route table, associated the route table with the subnet. So we're looking at the NACL now. Okay, so there is an NACL, which is now associated with the default VPC. So it's associated with the 4 subnets. And we look at our private VPC related NACL. So this is created by default. As you look at different things here, inbound NACL. So any NACL created by default within the private subnet allows everything inbound and outbound. However, if I create a new ACL, associating to the private VPC, so we have the test NACL, right? If you look at it, by default, everything gets denied. So this is an important distinction to remember. So by default, the default VPC and the default NACL created within the default VPC allow everything in and out. The default NACL created within the custom VPC allows everything in and out. But a custom NACL created within a custom VPC deny everything in and out by default. So subnet association, so sorry, we'll delete this, we don't need this. Okay, so this is our default NACL that was created when we created the private VPC. So, so by default, it is associated with the subnet. Upon rules, subnet association tags, files. So VPC is associated with alrighty. So nothing much there. So what we have done here is, so we created the VPC, we created the subnet, we looked at the route table, we looked at the NACL, make sure that they are associated with the subnets. So the rest we need to create is the EC2 instance, launch it within the subnet, and create a security group as we do the instance creation. So that's the last part remaining. So that's EC2. So let's launch a simple instance. So as we defined before, we have to specifically point to the private VPC we created. Subnet, it only had one subnet, so automatically gets assigned to that. So remember, we enable this option. So that's why it's showing enable here. Otherwise, it would show disable. So by default, we allowing to use the subnet setting, which is enabled. So it will get a public IP. So the rest, I'm not touching it. Add storage, standard ones, tag. It's not doing. Okay, security group. So I think we touched this before. You can create a security group when you are creating an instance, because the security group is specific to the instance themselves. And again, whatever configuration you're going to set here is only specific to the instance. So in our case, we're going to do a remote connection. So SSH, and we are allowing any source. So basically, whole internet can connect to this provider. It's not a good practice. I'm just doing it for convenience purposes. And we're creating a new security group. So can have our own name or leave this at the default one. Doesn't matter. Review and launch. I assume pretty much everyone knows how to connect to the EC2 instances via SSH using PuTTY. If not, I can go through that in detail in one of the sessions, but I'll quickly do that anyway here. So I'm going to create a new key path. Since I'm going to access it via SSH, let's give OC key, download key path. Okay, so I have to do a little bit of a tweaking here. So if you're using PuTTY, basically we have to convert the PEM to a PPK file. So we need to use PuTTY gen, load this file or files, save a private key. You need to usually put a passphrase. I'm not doing it for convenience. Right. So we got a converted PPK file. Now let's go to PuTTY. Let's get the public IP address from. Oh my God, I did not. Seconds. Okay, so this is the public IP of the instance that we have launched. So what we have done is we have created an EC2 instance under security group associated to this and launched it within the private subnet of our private network that we created, private VPC. So what I've done is I've copied the public IP. I'll go to PuTTY. So that's the destination. EC2 user, I'm sure for this username is EC2 user. Auth. Okay, let's see if we get connected. Can anybody tell me what's happening?
There is no internet gateway.
But we did saw internet gateway associated with it, right? Let's go back again. VPC.
That's initialized because we're showing this still initializing.
I think now it's fully initialized, but let me see, just to make sure that's not the case, because I'm pretty sure it's a different reason, but anyway, we'll check. So running instances, it's running live. So that was not the case. So this will be terminated, don't worry. Let's go back to VPC. I think somebody mentioned the internet gateway, right? So let's look at the internet gateway. Sorry if I don't get your name because it doesn't pop up when I do the screen share. Okay, so we have the internet gateway attached to the default VPC, right? So the VPC that we have here is the default one. So ideally what we need to have is we need to create an internet gateway specifically for this VPC. So let's create one internet gateway. Gateway. Okay, so we got an internet gateway. So as you can see, it's by default detached. So we have to attach it to a VPC. So we should be selecting our private VPC, attach, right, tags, don't worry. So that's attached now, right? So what we got is, so we got a VPC, we got a subnet, we got an instance, security group attached to it, and we have said, anybody can connect it via SSH. We have now an internet gateway. We have route table, NACL. So these two are associated with the subnet. And we got the internet gateway that is also associated with the VPC. Shall we try again to see if we get lucky? I'm taking bets. How many think will connect? Can anybody guess what's going on? Out tables. Yeah. So we have a default route and we have a custom route. So the subnet associated is with the, this is the, default route. So this is the custom, no, I'm getting confused. Okay, so this is the private VPC that came with this route table, right? So it gets associated with the VPC. and the subnet as well within the VPC. So that's fine. So we're looking at the right route table. So somebody mentioned routes. So what do we have here?
0, 0. Is it like you need 0, 0, all zeros for the
Correct.
internet? Is it?
So at the moment, the router only knows one thing. That is, if anything related to the side range, forward it inwards within the network. Anything else, just drop it. It doesn't know. So at this point, everything gets dropped off. So we need to add a specific route to allow.
Unless your PC is within that IP range, which not within this. Yeah. Okay.
So choosing the destination, internet gateway. We are choosing the custom internet gateway that we created. Save route. Let's see if this fixes the problem. I don't know. But... So that's the IP data. EC2 hyphen user. Sorry, not a great typer. Bingo. So again, this is basically cache related error. So you can just say yes. We are in. So just to check if internet is connecting, so you can say sudo yum update. So the instance can connect to internet. So basically that's connecting to the AWS and downloading the required updates. Yeah. So what we have done is, so we created our own VPC, we created our own subnet, then we created, we configured the NACL route table and internet gateway. So it allows both the inbound and the outbound traffic. And then we launched an instance with the security group, which also allows a particular type of traffic, inbound and outbound. Say, if, let's try pinging this. IP, it should not work. Let's see. Okay, maybe no, right?
Just do IF config.
Sorry?
IF.
Let me see one thing. I'm trying to do something else. Ping. So that's a public IP, right? So I should be able to ping from my end, right? But I'm unable to. Does anyone know why?
Yeah, because you didn't allow ICMP traffic.
Perfect. So that's the level of restriction that you can apply to the security group, where you can allow only certain type of traffic. So we only allowed SSH traffic, right? We did not allow ICMP. So that's why even though we are able to connect via PuTTY, but we're not able to ping it. And I think in the next section, I was thinking more in the lines of probably going for something like this, where we have a dual subnet, then we can play around with different requirements and configuring these. Then also we can look at additional things like some of the things we didn't touch yet. So the NAT, load balances, VPC rollups, and stuff like that.